Now we will finally talk about the ladder. Ladder is a very it's a object which we use to uh, climb surfaces. But what about the equilibrium of a ladder? When will ladder drop, or when will ladder be in its position? Imagine this is the ladder, and we imagine that this is a smooth surface and this is a rough surface. This is a rough surface, and the ladder makes an angle theta with the surface. So the rough surface and the weight of the ladder is acting through its center of gravity. So the rough surface, now the weight is distributed across the whole of the ladder. It is that the center of gravity is the point where whole of the weight, the sum of the whole weight appears to act, but weight acts along whole of the plane. So to oppose that, to oppose the, imagine that this is the ladder. To oppose the weight, there is a normal reaction force acting over here. Also weight is acting over here, so a normal reaction force is also being applied over here. This ladder has a natural tendency to slide in this direction. So friction, when it will slide in this direction, friction will act in this direction. So we can see that and the resultant of friction and normal reaction is the contact force. So we can see that, for example, the horizontal forces, this is also the normal reaction force. Okay, so if can this ladder be in equilibrium? Yes, it can. If the normal reaction force, the horizontal force, is equal to friction, if normal reaction is equal to friction and mg, and the vertical force is mg, and normal reaction force are equal, then yes, this ladder can be in equilibrium if these forces are balanced. But if the ladder, if the case is opposite, if this is a rough surface, this is the ladder, if this is the rough surface, if this is the rough surface and this is the smooth surface, can this be in equilibrium? This will be the normal reaction force. There is also the weight is going to act from the center of gravity. This is going to be a normal reaction force. If the this object is going to have a tendency to since this surface is smooth, there is going to be no friction in the horizontal direction. However, when this object will slide down in this direction, friction is going to act in the upward direction. So this is the friction force. So can this body be in equilibrium? No, because although the vertical forces, friction, the weight mg, the normal reaction force, they can be normal reaction force from the smooth surface on this ladder, although they can be same, but they can balance each other out. But what will balance the normal reaction force in the horizontal direction? There is no friction to do that, so this object cannot be in equilibrium. No, it cannot be in equilibrium. What if both of these surfaces are rough? What if both of these are rough? which is on a daily we see on a daily occurrence. This is the normal reaction force. Also this is going to be the contact force. If the body is going to slide in this direction, friction is going to be acting in this direction. This is going to be the normal reaction force, which is always perpendicular to the surface. If the body is going to slide down in this direction, friction is going to act in this direction. So so now weight of course is always going to act down mg. So can this ladder be in equilibrium? Yes, because the normal reaction force, it can balance the friction because they are in the horizontal plane. The normal reaction force in the horizontal plane can balance the friction in the horizontal plane, and friction in the horizontal plane can be balanced by the weight in the horizontal plane, which can be balanced by the normal reaction force if these are equal. So the forces in the vertical plane can balance each other out, and forces in the horizontal plane can balance each other out. That is why, because also another reason is this is the contact force and this is the contact force. If we also, the line of action of these forces meet at this common point over here, hence they can be in equilibrium.